Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. So we have a 13 over 3125. Now 13 over 3125, if I do prime factorization, I can write it as, let me write this here, 3125 prime factorization is 2 raised to 0, 5 raised to m. So for 3125, 2 raised to 0, 5 raised to 5. Hence the denominator that is denominator q, which in this case is 3125, is in the form of 2 raised to m and into 5 raised to n, where m is 5 and n is 0. And by theorem, we know that any given rational number of form p over q, where p and q are co-prime, has terminating expansions if q is in the form of 2 raised to n, 5 raised to m, where m and n are non-negative integers. And in this case, they are non-negative. One is 5, one is 0. So you can see this is a terminating decimal. For the next one, 17 over 8. So we know 8 is 2 raised to 3 and is 5 raised to 0. There is no 5 there. So 17 over 2 raised to 3, 5 raised to 0. Hence the denominator is of the form 2 raised to n, 5 raised to m, where m equal to 0, n equal to 3. So by theorem, it has a terminating decimal expansion. 17 over 8 has terminating decimal expansion, because the denominator has only factor 2. It should have only 2, only 5, or 2 and 5, no other numbers besides that. Now for 64 over 455. Now 455 on prime factorization is 5 into 91. So this is 64 over 5 into 91. So the denominator is not of the form 2 raised to n, 5 raised to m. Therefore 64 over 455 has a non-repeating it has a non-terminating this one, non-terminating repeating repeating decimal expansion. It will be non-terminating because of this 91. a number other than 2 and 5. That's why it becomes a non-terminating decimal. Now for 15 over 1600. Now this is first very important to reduce it. So you divide it by, reduce it 3 over 320 you'll get. Reduce it by 5. Always reduce it. So if you see that 320, you do prime factorization, is 2 raised to 6, 5 raised to 1. Here the denominator is of the form 2 raised to n, 5 raised to m, where m is 1 and the n is 6. Therefore the factors have not 6, it is 5 and it's 6. So the factors are only 2 and 5, right? No other factors other than 2 and 5. There's only 2 and that is 5, because it is 3 over 2 raised to 6, 5 raised to 1. So factors if you see are 2 and 5. Therefore 15 over 600 has a terminating decimal expansion. Next we go to 29 over 243. Now do prime factorization of the denominator. 243 is 7 raised to 3. So here the denominator, see it has got 7, no 2, no 5, there's a 7. That means it will be non-terminating. Here the denominator is not of the form 2 raised to n, 5 raised to m. Therefore 29 over 343 is non-terminating repeating. Decimal expansion. Now for 23 over 2 raised to 3, 5 raised to 2, they have already done the prime factorization of denominator. The denominator q is 2 raised to 3, 5 raised to 2. So we can say here the denominator is of the form 2 raised to n, 5 raised to m, where m equal to 2, n equal to 3 are non-negative numbers. Integers. Therefore 23 over 2 raised to 3, 5 raised to 2 has terminating decimal expansion. Now for the next here 129 over 2 raised to 2, 5 raised to 7, 7 raised to 5. We cannot reduce it. So we see the q is 2 raised to 2, 5 raised to 7, 7 raised to 5. So again here denominator is not of the form 2 raised to n, 5 raised to m. Therefore 129 over 2 raised to 2, 5 raised to 7, 7 raised to 5 has non-terminating repeating decimal expansion. So it is this one, terminating decimal expansion. Now 6 over 15. First important reduce it, becomes 2 over 5. So therefore we say Q is 5 raised to 1, or you can say Q is 2 raised to 0, 5 raised to 1. So here denominator is of the form 2 raised to n, 5 raised to m, where n equal to 0 and m equal to 1, and non-negative integers. So we can say 6 over 15 has terminating decimal expansion. Because it's 2 and 5, so therefore it is terminating. 35 over 50. First reduce it, always reduce. 11 over, oh that's wrong, that's reduce it. 7 over 10. So the Q denominator is 10, that is 2 raised to 0, 2 raised to 1, 5 raised to 1. So denominator is of the form 2 raised to n, 5 raised to m, where m equal to 1 and n equal to 1, non-negative integers. So we can say for 35 over 50 has terminating expansion. Next is 77 over 210. So you first reduce it, that is 11 over 30. So the denominator Q on prior factorization, which is 30, is 5 into 3 into 2. So this is basically 11 over 5 into 3 into 2. So thus we see that Q, here the denominator is not in the form 2 raised to m, 5 raised to n, and that's because of this 3. It is a 3 that is making all the difference. So we can say that 77 over 210 is non-terminating. Yeah, non-terminating repeating. That's all because of this 3. It becomes non-terminating. Write down the decimal expansions of those rational numbers in question 1, whichever terminating decimal. So I think the first one, that was 13 over 3125, was terminating. Now we got to write the decimal expansion. So we do first 13. Prime factorization of this becomes 5 raised to 5. Now you multiply this into 2 raised to 5, here also 2 raised to 5. So here you get 13 into 32, and this will be now 5 into 2 whole thing raised to 5. So when you multiply this is 416 10 raised to 5. So that will be 0.00416. It is 5 here, hence we have 1, 2, 3, 4, 5 decimal places. Now for the next one, that is 17 by 8. 17 by 8, you're going to write it as 2 raised to 3. So 17 by 8 is 2 raised to 3. You need to multiply it by 5 raised to 3. There's also 5 raised to 3. And on multiplying, you will get here 2125. In the denominator, you'll get 2 into 5 and whole thing raised to 3. So this is 2125 10 raised to 3. So it will have 3 decimal places. 2.215. There is 3 here. So 1, 2, 3 decimal places. So this is the decimal expansion of 17 over 8. Now for the fourth one. Third one was non-terminating, so we didn't do that. Third is 15 over 1600. So on prime factorization, 15 over 2 raised to 6, 5 raised to 2. So here we are multiplying it by, we need another 4 5s. So 4 raised to 5 raised to 4. So what you get in the denominator will be 15 into 5 raised to 4, and down you'll get 2 raised to 6 and also 5 raised to 6. You'll add 2 plus 4, that is 6. So this is 9375. 2 into 5 raised to 6, that is 9375 over 10 raised to 6. It's raised to 6, so it will have 6 decimal places. So 93775 and 1, 2. So this will be its decimal expansion with 6 decimal places. 1, 2, 3, 4, 5, 6, because it is 6 here. Next, the sixth. The fifth is non-terminating, so we don't do that. So for this one, we have 23, 2 raised to 3, but 5 is just raised to 2, so we need another 5. So we do into 5 raised to 1, 5 raised to 1. So when you multiply this 23 into 5, you'll get 115, but now you get 2 raised to 3, and 5 is also raised to 3. So 115, 2 into 5, whole thing raised to 3. So 115 over 10 raised to 3. Raised to 3, that means 3 decimal places, 0.115. It will have 3 decimal places. Next, we get on to the 8th one, which was 6 over 15. 6 over 15 is 6 over 2, not 2, it is 15. 3, we got to reduce this first, right? So 2 over 15 is, 6 over 15 is 2 over 5. Now the 2 over 5 will multiply here by 2 and this also by 2. So we will now get 4 over 10, which is 0.4. Now for the next. So next is 35 over 50 here, 7 over 10, that is 0.7. Terminating, and this was a decimal expansion. It had 1 decimal place. This has also had 1 decimal place. This, however, had 3 decimal places. You can find out without division. The following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational and of the form P over Q, what can you say about the prime factors of Q? So first let's go over what are rational numbers. Rational numbers, those that can be written P over Q, they're all rational. Now among the rational we have two kinds. We have the terminating and we have the non-terminating. Now in the terminating, the denominator is in the form 2m 5 raised to n, and in the non-terminating the denominator is not in the form 2m 5 raised to n, means it has factors other than, it can have 2 and 5, but it has got factors other than 2 and 5 also. It will have 2, 5 and other factors. And here it has only 2, only 5, or 2 and 5. And so rational numbers are written P over Q, and they are made up of two parts, terminating and non-terminating. So let us take up the first one. This is now 4, 3.1, 2, 3, 4, 5, 6, 7, 8, 9. So I can write it as 4, 3, 1, 2, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Over there are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 raised to 9. So if you see, I wrote it as P over Q. So if it is P over Q, definitely it is rational. And if you see it is terminating here, there is no continuous dots as such. This is a terminating decimal. It is terminating. So if it is terminating, it is this case. The denominator, that is Q, is in the form of 2 raised to m 5 raised to n, where m and n are non-negative integers. So this is how I can comment about the denominator. The denominator is the Q. It's in the form of 2 raised to m 5 raised to n because it is terminating. It stops here. There is nothing after this. There are no zeros after this. Now for this next one, if you see it's got these points, so definitely it is non-terminating. But it is also non-repeating. Have you seen there is no pattern as such? So it is non-terminating and non-repeating. It is not repeating only. If it is non-terminating and non-repeating, it is irrational. If it is irrational, it cannot be written P over Q. So we cannot comment on its denominator here. We cannot comment on its denominator. Now for the third, if you see there is a line, because there is a line, we can say it is repeating. That is what it indicates. It's repeating. And definitely it is non-terminating. That is why it is repeating, right? This is a repeating, non-terminating. If it is non-terminating, that means the denominator, which is Q, is not 2 raised to n 5 raised to m, because it is non-terminating. It is not equal to. So we can say prime factorization of denominator has factors other than 2 and 5. It is not on the form of because the meaning of this is repeating. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, and it goes on. Non-terminating, it is non-terminating but repeating, however. So it is a rational number. It is rational. It can be written as P over Q. But its prime factorization is got other than 2 and 5 because it is non-terminating.